1.5 gram of an impure sample of sodium sulfate dissolved in water treated with excess of barium chloride solution when 1.74 grams of barium sulfate were obtained as dry precipitate. Calculate the percentage purity of the sample. So in this particular one, we know this much amount of sodium sulfate is already impure. So we need to know how much the original mass of sodium sulfate participated in the chemical reaction. So the purpose of the reaction is to find the mass of the sodium sulfate originally taken part in the chemical chain using the equivalence of barium sulfate. Now in the question it was clearly mentioned sodium sulfate is reacting with barium chloride to give barium sulfate. In this particular one, it was mentioned clearly barium chloride is in taken in excess. So the minute it is in excess, we no need to consider this particular part. So this becomes your limiting reagent. Na2SO4 becomes your limiting reagent. So automatically, whichever is the limiting reagent, with respect to the limiting reagent, the equivalence becomes. So the number of equivalents of Na2SO4 will be equals to number of equivalents of barium sulfate. So the product of a chemical reaction will always be equal to the equivalence of limiting reagent. This is law of chemical equivalence. So according to law of chemical equivalence, the equivalence of the product will always be equal to the equivalence of the limiting reagent. Following this particular one, number of equivalents is equals to weight by equivalent weight, weight by equivalent weight of barium sulfate, which is equals to weight is given 1.74 by equivalent weight is molecular weight by 2. N factor is 2 for this, which is 1.74 into 2 by molecular weight of barium sulfate is 233, which is equals to 3.48 by 233. Now let us come to this particular one. Number of equivalents, we have got number of equivalents of sodium sulfate. Now how can you write the number of equivalents of sodium sulfate? Weight by equivalent weight of sodium sulfate, this is for Na2SO4, will be equals to 3.48 by 230. We don't know the weight, but what is the equivalent weight is molecular weight by 2. Molecular weight of sodium sulfate is 142 by 2 is equals to 3.48 by 230, which clearly indicates W is equals to 3.48 into 71 by 233, which will clearly come up to 1.06 grams. Now the question comes, percentage purity. If I want the percentage purity of this particular compound, what is the percentage purity? Now the question comes over here. Percentage purity of Na2SO4 will be equals to weight of pure sample by weight of impure sample into 100. We got the pure sample is 1.06 grams. Weight of the pure sample is 1.06 grams. Weight of impure sample we will be getting. Impure sample we have is 1.5 grams into 100, which comes to be 70.67%. So the percentage of purity is 70.67%. So the answer is 70.67 percentage.